Thank you so much for inviting me, and I literally couldn't believe my luck to see you invite, because I've been watching what you guys have been doing for the past year, and literally most of the stuff that I'm going to show you, you have already done. So I think this is a case of convergent evolution by groups with very different backgrounds, perspectives, and also very different means. But anyways. My background is actually in cognitive linguistics, and for the past 2 years I've been in a machine learning lab, because why not? I'm finishing my postdoc with Anna Rumshinsky, but as a linguist, I've always wanted to see that happen. I've wanted to see that computers can actually understand language, and I kind of gave up linguistics because I was frustrated about having all these beautiful theories which you have no way of testing and no numbers at all. However, when I moved to the world of NLP, I found that there were plenty of numbers, quite enough. Well, if you look at this, language has been solved, right? We are past human performance. Way past. And also, if you read the newspapers, then that's the impression you're going to get, because well, we are being superhuman on a diverse selection of NLP tasks. And this is from yesterday. I'm not sure if it has already changed. It might well have. The most frustrating thing for people who make datasets is whatever we do, it gets solved almost immediately. So superglue is being presented as we speak in New Reps, right? And we are 1 point away from human performance. I think what happened to QuAIL is also an illustrative story by this point. I had the pleasure of being in the talk in NACL where it was presented. And by the time it was presented, it was solved. Yes, what do we do as people who want to have the data that actually poses a challenge if whatever we do just doesn't seem to work? Except, of course, it's not actually the case that we have solved language. This year, I think, has been remarkable for NLP community in that we have had all these beautiful papers with a steady stream of bad news. So we have seen that we are not actually solving the tasks. We are just learning some shallow heuristics, such as lexical pattern matching. These guys broke Squad, and these guys broke NLI. We also should know that we are just learning artifacts, some spurious factors in the data that just happen to correlate with the correct label, and that's a very easy way out for the model without understanding anything about language at all. We are learning datasets rather than tasks. Even within the same domain, we do not necessarily generalize. We are learning annotators rather than datasets. And we can't even reproduce what other people have done. This paper titled Questionable Answers and Question Answering Research has shown that even the version of your linear algebra library can make a difference. And some factors, such as random seed, will make more of a difference than the improved performance that is reported in many deep learning papers. And systems can be easily attacked, and this paper inflicted an existential crisis on me because, well, if this is the case, if we have those universal triggers, we can find them for any data set because of Zipf's law, because there will always be rare things that are unambiguously associated with a particular label. And last but not least, so this is one piece of bad news that I have presented in EMNLP. We don't actually even need to train BERT. Depending on the task, a randomly initialized model fine-tuned on the target task will do almost as well. You will get 80% accuracy in sentiment analysis without any language knowledge whatsoever. So this is all very depressing. And I think this all comes down to one thing. Our datasets do not require the actual linguistic knowledge that we want to capture to solve them. And then the question is obviously, how do we make something more difficult? How do we make something that the model cannot just solve with some trick? So one of the directions in which people in the QA community have been looking at is adding the unanswerable questions. So at least you have to know when you don't know. Then there's obviously multi-hop reasoning, where you have to construct some kind of reasoning chain to arrive at the correct answer. Adversarial data generation, people in this room. So here you will try to put the model in the loop and reject any data points that it can solve easily. Then there's the approach where you don't show people the text for which where the answer is supposed to be found. So this way you encourage some kind of paraphrasing. This has been done for news. This has been done for narrative texts. And last but not least, the multi-dataset, multi-domain, multi-task learning, where at least the task is made more complicated by the model being forced to generalize. And this is the direction that I have been trying to pursue for the past year, and I think this is the point where we converge. The dataset that we have made is called QuaIL, and it has finally been accepted for AAAI. This contains 800 texts which we handpicked from 4 different domains. The texts are rather long compared to Squad, and we, with our budget, were able to generate 15,000 questions. We have tried to pose a few challenges in this dataset which we have not seen combined. So one thing would be that we will have several data domains, and importantly, we are trying to combine the sources for which you could possibly find the correct answer elsewhere, and those for which you couldn't. So for fiction, for Quora user stories, you can assume that the context is unique. And unless, well, you have some kind of control over whether this was likely to be in your pre-training data or not. For me, it is very troubling that we can train on Wikipedia and then say that we solve Squad, which is the BERT paper. So we're trying to not do that. We're trying to have genres in which you have both open and closed world settings. The other challenge that we tried to do was, well, as in the title of the talk, we were trying to combine 3 different settings of certainty. We were trying to combine the text-based questions, the unanswerable questions, and also the world knowledge questions, which we have text-based and unanswerable questions together in Squad 2. We have plenty of world knowledge datasets, but I have not seen all 3 put together. And my rationale for that was, well, people can do it. So suppose you want a new laptop and you have a few questions about which model is good. If you want to know how much RAM there is, you know where to look. You know that you can just go to the page and the answer will be there. You will be able to do some reasoning for questions that are not in that page. So if you want to know how you will look in Skype calls, you can look at the photos and you can deduce. So this is an example of world knowledge, as opposed to text-based questions. But then there's also questions for which you know that you don't know. You will not know how comfortable the keyboard is until you have spent some time with the laptop. So humans can do it. Why don't we try to have machines do it? And challenge number 3, this is where we converge. Well, we've been trying to have all of this in one data set so that we could see how the models do on different types of different types of questions. Here we have 2 challenges, actually. So one is to be able to generate those different question types, and to have a record of which question is which type, so that we can say how we're actually doing on different question types. So one is to generate that, and 2 is to be able to balance that, because for some types of texts you will have causality questions more easily than for others. And this was actually a case of opportunistic sampling of genres and question types. So we looked at different genres and we tried to find those for which we could find a coherent set of questions which could be asked for all of them. And of course, this is not by itself very plausible. This does not represent the full amount of genres. The rationale for this, though, is that if you don't have the balance of different question types, if you don't know which ones are which, then you don't know what you're actually solving. My favorite example of this was this property of BERT embeddings, which we have all learned in 2013, and which made big waves. Except if you actually look at a wider range of relations, you will find that, okay, this is the country capital, and all the rest of lexical relations actually don't hold. So I've been trying to make sure that we can do the same for question answering. We can see which question types we could solve and which we could not. And for the final challenge was to do all of this with one postdoc and 5K. So please don't judge. This was painfully slow, but still I'm very happy to be able to share what we have learned, because I do think this is a case of convergent evolution on many cases, on many points. So the examples of texts that we were able to get, so the texts are about this length, and well, yes, it's pretty long, and we will have the temporal order questions, recently done by people in this room. We will have the character identity questions, ideally co-reference questions, but we found that Turkers did not really know what pronouns were. The factual questions, which is the type that you will find most frequently in existing datasets like QuAIL. The causality questions, the questions about what probably happened after event X, which could be in the end of the text or not. The questions about event duration, also recently published by people in this room. Questions about likely entity properties, which I think is the most overlapping with the world knowledge questions, because this is usually inference about what is true about a character given that he did X. The belief states, this I actually haven't seen anywhere else, but this could be either the what does the character probably think or believe, or what did the character say if it wasn't actually mentioned in the text, like if you have dialogue. And finally, unanswerable questions, which we did not restrict by type, so it could be anything. Provided that the answer could not be answered or found or guessed from the text. So for data collection, we did the following setup on mTurk. We presented the same text to 2 Turkers, and each of them wrote 9 questions. As always, we had those reliable native speakers. And we found that it took them on average 30-40 minutes, and being poor researchers, that's what we paid. So yes, there's plenty to unpack on each of these lines, but let's go on. In the form, we had specific examples for each question types that we wanted. It was about like this. So we were showing the text on the left, and this was scrollable, and we showed the formulation of the task, an example for that domain, for that task, some more ideas that they could draw from, and then this form which asked for the question, the correct answer, and plausible answers. This was arrived at after much experimentation, and of course still wasn't perfect, but this is the setup that gave us the most consistent results. And we tried to do this with three different strategies. We actually started with trying to crowdsource the data and then to have it checked additionally by non-Turkers, by students. Then we experimented with automatic checks, and finally we have a small experiment where we did the annotation ourselves. For fiction, we tried to do this. We generated all the data with Turkers, and yes, so just using this form, whatever they wanted they could put in. And then the students had to check whether the questions made sense, whether they were of the correct type, and whether only one answer option was correct. And these were 3 undergrads, and I'll show what happened in the end. And the other setup was where we didn't have any human post-validation, but we had additional built JavaScript checks based on the keywords for different question types, which we have collected from raw data. You would expect that this would yield much higher quality than this, right? Because at least there were 2 rounds and people were not Turkers. However, when we actually compared the samples by annotating 180 questions for each procedure, we found that the chief advantage of this extra processing step was that the students just corrected more typos and grammatical errors. When Turkers say that they are native speakers, which our form did ask for, our hit formulation did ask for them to identify as native speakers, that is definitely not the case in for many Turkers. There's typos and there's errors that suggest that they were not actually native speakers. So this the students did manage to fix, but for the answer problems, actually we didn't see that much of an improvement. So most of these problems means that there was more than one correct answer according to us, and the students did not manage to reduce it that much, and I will come to this point again later. And for the wrong question types, actually the students did worse. Oh, sorry, this is wrong. So the students had more incorrect answer types than with the automatic keyword checks. Additionally, well, this is what we learned from all of this. We can say that yes, post-editing will improve your language quality, but the chief thing here that we found was that actually when you have this extra layer of checking by a small number of people, you will have what Goldberg recently found. This small number of people will come up with their own strategies, and that will introduce an extra level of bias. So we found that there was a consistent type of error that the Turkers actually didn't have, but the student introduced. So probably, based on everything we've seen, probably the best strategy would be to just have as many people as possible and not have one person check it all. The good thing that we found was that these automatic checks that we had, they had something of a Hawthorne effect. So you know, this is the effect where people tend to wash their hands more if they see a pair of eyes on the poster staring at them. So the effect of having these extra checks, which only were checking for the question type by keywords, it had the effect that the Turkers were less prone to just copy-paste the example and paste it in the fields, which they were doing a lot when they didn't have this extra check. So overall, the quality of the questions improved when they thought they were being monitored. Okay, one more thing was that we had a lot of trouble with coreference. I'm not even sure we should say that that question type was coreference, because about 25% of it is actually just character identity questions, like who is John? John is a student. Because when they were trying to formulate a question with who, they often just went with the factoid questions that also started with who. And the most common type of error for question types was that they were generating factoid, simple questions instead of everything else, which to me says that this is probably what we get if we don't restrict the question type at all. So these, I'm sure, is the majority of questions in datasets like QuAIL. And we didn't actually manage to get very consistent results for this discrepancy between text-based and world knowledge questions. So in the instructions we said, okay, the causality questions, the answer should be clear from the text. We intended it to be a text-based question. But in many cases, when they couldn't find anything directly mentioned in the text, they wrote a question that involved world knowledge. So I would say that some categories are actually in between. They're a mixture of text-based and world knowledge questions. And another thing that we found that is consistent with what other people have found recently is that people are not very creative. They will go for the most obvious thing most of the time. So we had a lot of questions. Each text was processed by 2 people, and we often had these 2 people generate identical questions for the same text because they were going for the most obvious thing. Okay, so let's look at the human evaluation for all this data. And again, our rationale for combining text-based, common sense, and unanswerable questions was that people can do it, we do it in real life. However, if you present the whole range of questions as is, so as I showed you, all questions in one form and the option not enough information for every question, you will see that human performance is not as great. It's only 0.6, the Krippendorf alpha, between the Turker and 2 annotators. And you will see that it's a bit better for the questions we intended to be text-based, so temporal order coreference, that's better, but something like duration is particularly bad. People will not be very confident at discerning those from unanswerable questions.
These
yeah?
accuracies, or?
That's Krippendorf alpha. Yeah, so the Turker and 2 annotators, which were not Turkers. It's, I think, very important to in the community to realize that human performance is not the same as Turker performance.
So these are inter-annotated?
These are 2 students versus 1 Turker, so 3 labels. Yes. So these people were not just, they were trying to actually answer the questions. They were volunteers. When we tried this with Turkers, it was even worse. However, if you try to exclude the common sense questions and have what we have in Squad 2, you will see that the alpha will improve by much, just because you don't have this full range of uncertainty. So the Squad 2 setup is easy compared to the full setup for humans. And if you do just the world knowledge questions, you will also see the improvement, even though here we did leave the option not enough information in. So the only thing that was different was that the unanswerable questions were not in. So this is not, I think, the kind of contribution you expect to do in an NLP paper. But we learned something about humans as a result. So we are not comfortable performing this task as we feed it into the NLP systems, which I think means that we have to face the question of different pragmatic settings for the model and for humans. For humans, we can frame the task differently. We can say, okay, you can think of picking the option that you think is correct. You can think of the option that the author of the question probably meant. You can play with different wording, with different formulation of this not enough information option, but you can't do this for the machine. And it will make a difference for humans, and it will not make the difference for the machine. So we have to see how what setup would even be fair.
Sorry, just a quick question. So you showed the Gryffindor Alpha
Yeah.
scores. What was the average actual scores of people?
How many questions they got correct?
Yeah.
We didn't calculate that. But yes, we should. I agree.
You could have an alpha of 0.6, but they're still getting 80% right, for instance.
That could very well be the case, but still, we do want some kind of agreement, right? So another thing that I think is a factor here is that this estimating uncertainty, well, it's a cognitively taxing task. When we do it, we try to avoid it actually. We often wish we just can flip a coin and decide whether to buy that laptop or not. Because it's too many things that we don't know the answer for, and we don't want to have the trouble of trying to estimate. So again, this is something where the machine actually has an edge, because it doesn't have the same set of biases, the same set of cognitive problems as we do. So okay, this is how humans do, and it's not great. So what about the models? We had this set of baselines starting from something very stupid and obvious, like pick the longest answer, average cosine similarity between word embeddings, the hidden states of LSTMs, just PMI and information retrieval solver that's run on the text and the question answers. And then the Trian, so this was the winner of the Semival 2018 competition, which had this dataset and the script, which was the most similar in terms of format to what we had when we were doing this. So this explicitly includes ConceptNet, and this was supposed to help it with common sense reasoning, and of course BERT. So one of the things that you see here is, okay, when you do have the question type annotation, is well, you can get the breakdown by different question categories, and the combination of all those different baselines, including some that are tailored to check for just simple heuristics, it can tell you where your data may be problematic. So you can use this to diagnose both the models and the data sets. So PMI does much better on text-based questions than on world knowledge questions. This is to be expected, but this also shows that there wasn't much paraphrasing. Many of them probably can be solved with just simple lexical matching. And the long choice, this very stupid baseline, is doing very well on causality questions, which points to an artifact. Probably people were more willing to spell out the correct reasoning than to think of equally detailed incorrect reasoning choices. Okay, factual questions are the easiest for both Turkers to write and for models to solve, and that's probably most of the QA data that we have had until now. Now, consistent with, again, a chain of recent papers that we're trying to use BERT to induce world knowledge, it actually beats Trian, even though it doesn't include any explicit world knowledge resources, even on world knowledge questions. So I guess that's another piece of evidence for these large pre-trained models being able to somehow deduce much of what we call world knowledge from just co-occurrence data. And the surprising thing is, if you remember this human evaluation form where we had very poor scores for unanswerable questions, models are actually doing much better on that. Even though the setup is exactly the same. So it's a case of how do we formulate the task for the humans so it's fair as compared to the models. Yep?
What's the average cosine baseline here? Because it seems like that's the extreme. I wouldn't expect that to be correlated.
Yes, and that's so we didn't do anything special for the unanswerable for the not enough information questions, right? So these words were probably not even in the text.
Sorry.
So we didn't do anything special for these answer choice not enough information. So it was just a similarity between these words not probably even present in the text and everything in the text and the answer. I don't know how.
That suggests that the unanswerable questions are like kind of question about a paragraph
Mhm.
of text, which on the surface looks like it might be answerable from it, but actually isn't. Whereas I could also ask you like some completely random question about like an animal or something, which is obviously not answerable from a paragraph of text about finance data. Does that make sense? Like.
Right. I'm not sure. This is really surprising because yes, it shouldn't be doing well at all. But it couldn't have arrived at that just based on the amount of words present or not in the text, because for many of world knowledge questions, the answer options were also not present in the text. So if it were just I don't know, trying to reject things based on PMI or something, it wouldn't be able to do this for these questions. Yep?
Does the average cosine baseline use the question text at all, or is it just the of the options and
I think it's everything in the text plus the question plus the answer option versus the answer option, and then you pick the yeah.
And BERT is fine-tuned on the training set.
BERT is fine-tuned on the train set, yes, and this is the test results. And this is training on all domains, and the test set also for all domains.
And your training set was about 10,000?
It was 30% of the data, so 30% of 15K, so not that much, yes. Okay, so one more experiment that we did was, okay, what if we paraphrase? What if we try to make it as difficult for the models as possible? This was in an act of utter desperation. We just edited 500 questions ourselves, and I have a long set of heuristics that I thought would make different types of questions more difficult. This also checks for the question type and answer correctness. So here, what we did was different for different questions. Say for coreference, we tried to make sure that the distractors were mentioned close to the original, to the correct answer. For factoid questions, we tried to make sure that none of the options could be found in the text. So what we did was different by question type. And if you do that, you will see that some of our heuristics are more effective than others, but overall, in many categories, for both Trian and BERT, they drop to almost chance performance. Chance performance is 25%, right, for choice dataset. Especially on factual questions, you see that both models suffer a lot if they can't find exact lexical matches. Again, the gains, well, the losses were different by question types. But the human evaluation did not improve, and this was very disappointing, because we thought, okay, maybe we had such bad human evaluation because somehow the correct answer wasn't distant enough from incorrect answers. So we, the experts, let's make it as clear as possible. Nope. It's very hard to make sure that the world knowledge option that seems obviously the only correct one to you is also the only correct one to everybody else. I had a very vivid piece of evidence for that last Saturday, when I had to take IELTC to prove that I can speak English for Australia. This has a reading section which you have almost an hour to solve, and it has extractive and abstractive questions, and they were written by people who were paid a lot of money to write valid questions. And after all this, after all these years of being trained as a linguist, I spent like 10 minutes trying to solve one extractive question. So this is very hard, and just because we also have this variation in backgrounds and reasoning that we use to perform. Okay, so do domains matter? Because we have this domains by question type designs, we can also check whether we have any problems due to different domains. And you can see that, yes, there is a difference in how BERT does on all these question types, on all these domains. And you see in particular that the news unanswerable questions are very easy, suspiciously easy. Even though it actually doesn't have any news data in the training set. And if it is suspiciously easy, well, probably the Turkers were copy-pasting a piece of text from there that somehow made it easy. So the point that we'd like to make here is that this lets us test not just the cross-domain robustness of a model, but also the datasets themselves, whether some types of data were more or less difficult to generate with a particular kind of data. Okay, one more experiment we did was whether there would be any benefit from ensembling different models. This shows, so the blue is the number of models which BERT and one of these models got correctly. And you see that actually the most successful models, they have the highest number of shared questions that they could answer correctly, which means that what they're doing is not so dissimilar. And they have a relatively small number of different incorrect answers, which would show that they use some kind of different strategies. Overall, there may be some leeway by, so Trian has some questions that it can answer, but BERT cannot, but overall, not that much. BERT does not have much to learn from either of these models. Okay, so to talk about the limitations of this study, obviously, it's not great that we had a mixture of data collection, so our fiction was generated differently from all the other domains. And if we had the resources, we would redo that. Then we used the multi-choice question answering format, which has a whole set of its own problems. It is very fair to say that any setup in which the answers can see the writers of the question can see the text are not realistic, because that's not how we usually ask questions when we actually want to know the answer. Then again, the choice of question types that we ended up with was based on all possible types of reasoning we could think of that could be asked of all these different texts. So you could say that, okay, this is not aimed at any particular application. But then also, if you do have different question types which you have annotated, then you can adjust the dataset to whatever your actual application is, because you can mix and match. So this might actually be an advantage. What we have learned. We have learned that this combination of questions is trouble, and it's trouble for a fair evaluation between the human and the machine. We have learned that on the positive side, it is possible to generate questions of specific types, and so we can strive to have annotated balanced datasets which would enable all these detailed diagnostics that we can do. This can also be used to check both the models and the data. The bad thing is, even with all these attempts to balance things, each of the categories will inevitably have its own sub-biases. And even though it's better than to have the whole dataset biased in the same way, well, essentially the problem, conceptually the problem has not gone away. For question generation, we found that this question type validation works remarkably well, probably due to Hawthorne effect. I guess this is kind of obvious to anybody who has tried to work with Turkers, but yes, if allowed, they will just generate factoid questions. And it is really hard, but not impossible, to get them to do anything else. We have learned that we should just probably strive for as much diversity in both questions and in both texts and questions and workers as possible. So just try to collect all the different data points from all the different people in all the different ways. And that would probably be the best way to avoid biases induced by a single annotator. So a lot of the questions that we have generated, they were similar to the examples we showed in the form, and that also suggests a way to generate more diverse data, because you could vary the stimuli, the examples that you show to different groups of Turkers. So that could probably also be a way to get more diverse data. And one thing that we really should have figured out is that when you just say unanswerable questions, well, that's a lot, because unanswerable question can be an unanswerable causality question or unanswerable temporality question or anything else. But guess what did we get? They were mostly unanswerable factoid questions, as in QuAIL. So to really have a data set which could teach a model all the diverse reasoning strategies, we would have to balance everything pretty much. So for future work, we would definitely need to revisit the news domain and see what went wrong there, why the unanswerable questions are so easy. We would, well, this is in the works, we would love to try to paraphrase more of the data set. And to try to do that with Turkers, again using the Hawthorne effect. An interesting direction, I think, to do would be to experiment with nonsensical, with adversarial distractors, and with their number, because well, extractive question answering is kind of also multi-choice question answering, except that you have all these different options which are much higher in number, but most of them don't even make sense to humans. So it would be interesting to see at what point does and at what level of relatedness to the correct answer we can see that it actually makes things more difficult for the model. For duration questions, they were remarkably difficult for humans in our evaluation. So I think one thing to do would be to experiment with non-typical duration units. People usually just say, so how long did this last? They just say 5 minutes or 20 minutes. So something very stereotypical. So if you could reformulate the question in terms of, well, not seconds, but something which this type of event is normally associated with, maybe that could make a difference, and also involve all these interesting quantitative reasoning properties of the models that you guys have been working on. Also, well, I have tried myself to increase the interval between plausible and implausible options. So how long will it take to drive to Boston? It could be 3 hours or 5 hours or 20,000 hours. And obviously one of them is much easier to discard for the human. So it would be interesting to experiment with how big of a gap does it have to be for humans to be able to get reliably good performance. So thank you very much. We are working on getting everything online, and I would be very happy to have any comments.
You have plenty of time for questions.
Yes.
Is this a data set we should be working on?
Well, we will definitely put it online. Okay, honestly, I don't have high hopes. I think somebody will solve it within 2 months, like everything else. But I think at least we have experimented with different data collection strategies, which could help us to find even harder things.
The one figure I'm missing, I guess I don't know whether the best performance, like 55% or whatever, Is that as good as you can get with the data sets, or is this like 30 points below human performance?
Well,
you haven't taken the human performance measure on it, or have you?
Well, we have, and yes, and so the human performance is 0.6 if you get the if you take all the questions,
Okay.
right?
Okay.
And then our best model BERT is slightly below that at the moment. But again, this is not really fair because humans get better accuracy if you just partition the data differently or present them with a different formulation of the task. So here we have a fundamental choice. Yep.
Can you say more about the paraphrasing that you did?
Right. I have like 12 pages I can share.
So
yeah.
you're changing the text of the question to make it what? To make it like the answer stays the same. You're making it harder.
So I tried to experiment with everything. So obviously, what I did depended on what the Turk is generated to work with. Sometimes the answer options were all obvious by themselves, and you didn't even need to look at the question. And in that case, I was trying to make sure that either none of the questions and none of the answers were in the text, or they were all in and close enough. Because that's also hard to do, but do we have more time actually?
Plenty of time.
Oh, excellent. Okay, I actually have a few slides with questions with no answers, which I think we should just try to work on more. Generally, what can we do? How can we make questions difficult? So if you look at this, John bought a red car. What kind of car did John buy? Actually, in either format, it's a very easy thing to solve without any language reasoning, right? So here you just need the text concurrent count, and here you can just solve it with large corpus concurrence, or in the same way if you allow the words from the question as correct answers. And if you try to do this, if you try to add destructors which are also present in the text, so John bought a red car, Mary bought a yellow car, now you have both red and yellow, and they both kind of make sense. But actually, this is still doable with PMI just because you will find the closest thing, right? So you still don't need any real reasoning. Doing this, your ability to be able to do this depends not just on the on what you want to do, but on the text. If you don't have any other colors in the text, you will not be able to ask a good question like this. Also here, the problem with extractive format, I think fundamental problem is that most incorrect answers are just easy to reject because they don't make any sense in terms of concurrence. So you kind of have more options, but then you also kind of have fewer options because only a few of them make sense in terms of concurrence. Then here we have the problem if we try to paraphrase just the question. So now I don't have car, I don't have John, I don't have buy. And this is kind of what I was trying to do in that paraphrased small data set. So to make sure that no, nothing in the question is in the text. So you cannot just identify one relevant sentence. Well, the problem is that the model can just ignore the question altogether, and that was our best baseline for SEMEVAL 2018. If you just ignore the question completely and just find the one option that is the closest to the text, you can still solve it and not do anything actually by way of reasoning. In this choice, in this case, actually, the structure of the multi-choice format, it is actually worse because all the answers will be coherent. They will make sense for humans, right? So the red and blue and yellow, they're all colors, and that in itself gives you a hint that you should be looking for a color. So that will tell you what you're more likely to need to answer. With the extractive format, obviously, you are limited to whatever you had in the text. So let's try the double encryption. Let's completely paraphrase the question so it's not in the text, and let's also do something completely crazy with the answers. Because this is multi-choice format, we are free to write whatever, so we can do it. Not like here, but then this double encryption, well, it's definitely not representative of any kind of questions we're actually handling in real world. So even if we can accept it as a way to test language knowledge, nobody will say that this is a valid question answering data set. So yeah?
Do you think that this question still has a lexical cue like vehicle and car? Wouldn't it be completely agnostic about text if you say something like what kind or what is the color of John's purchase, for example?
What is the color of John's purchase? Okay, you could do even that. So that would still anchor you to purchase and buy, right?
Yeah.
Yes. So to ask a question that would be completely untransparent with respect to text, it's difficult. And if you do manage to do that, well, is that even what we want to do? Basically, yeah, I don't have the answer for this, but I was hoping we could start thinking about this together, because everything I have shown you, it doesn't actually require much of language skills to solve it, none of this. So even if you go completely nuclear. So we need to switch to free-form answers somehow, and you guys have shown that BERT is not the solution to that, but I guess we need to keep thinking.
Sorry, go ahead.
I guess, so going off from that, so there are two things that could happen, right? As you're making this progression, either you end up in this kind of unnatural setting where you have this double encryption where the questions seem very awkward, or you end up in the setting where the text is very complex, you have like 10 passages and you have to go through them to keep the co-reference chain in mind and then answer the question.
Right, so that's the multi-hop reasoning, and,
Right.
and I guess that's a different way of thinking of how we can form different questions. But that's kind of throwing in the towel for the lexical matches, right?
Right. I guess even with the textual matches, I guess where I'm going is eventually maybe you make it model hard, but it becomes human hard too, right?
Right, and that's also something that we saw here. Even this just this combination of questions in itself makes the task somehow more difficult for humans than for the model.
Right, so it's, I don't know, like it's a catch-22. You try to make it model hard and then the gap.
Yep.
You still don't have a big human machine.
Oh yes, definitely. And also for multi-hop reasoning, well, I haven't worked on multi-hop reasoning, but I have taught English for a long time, and there's definitely a cognitive limit on the amount of text that a human is willing to process to find an answer to a question. So you can definitely go implausible there as well.
So this actually, all of this makes me like sort of, I was already sort of doubtful, but now even more doubtful that we should be targeting sort of human style abilities as the goal, since humans are not as good at this as we think, or there's at least tremendous variation in what humans, take your world knowledge example, right? There's a lot of variation in what people think of as world knowledge.
Yes.
Or what world knowledge people have. We don't all match. So this leads me to feel like very much more optimistic about QA as defined toward a real application, right? Which is maybe more sane. We can say these are the users we have in mind. These are the kinds of texts they're going to be interacting with. This is the kind of questions they're going to ask. I wonder if you have thoughts about fruitful directions that are maybe a little bit more on the ground instead of this sort of general capability and matching humans. Instead, we think, what do humans want because they're not good at it, and where can machines fill in the gap and create something useful? And maybe you have thoughts about that.
Well, I think people are definitely already making use of the machines for the ability that the humans don't have, namely being able to process all the text.
Yep.
Right? So as long as the answer can be found or deduced with relatively shallow matching, we already have it, right? We already have it. Well, that's what Google Assistant is trying to do. Except that, of course, it will rely on those shallow matches instead of actual language reasoning. But if you try to go in the direction of checking what language reasoning it's capable of, then you end up here.
Yeah.
So I don't know if it's, well, basically I think you're asking about narrow AGI and
Sure, or just useful.
It is already useful. It is already useful. It is already doing, I think, what a lot of what we can hope it to do, except that it doesn't use language to do it, and we don't know how to test, how to either teach it to do so, or to force it, or to check that it does.
I think I'm going to end on a more public note. Okay. Anna's here all day. Hopefully a lot of people will get a chance to chat with her. Thanks so much for your talk.
Thank you very much.